Okay, so 10.1 is applying the counting principle and permutations. Okay? It starts off by saying a sporting goods store offers 3 types of snowboards: all mountain, freestyle, and carving. 2 types of boots, soft and hybrid. How many choices does the store offer for snowboarding equipment? How would you normally set this up?
Um,
How would you figure that out?
I mean, like an equation,
It doesn't have to be an equation, just how would you,
or just sort them out. I mean, it's just like put like the name of the.
okay, so like all mountain, right?
Mhm.
And then there was freestyle, and then there is carving, and then there are 2 types of boots, yes? Soft, hybrid. And normally, we would just match these up, like there's 1 option, there's 2 options, right? 3, 4, 5, 6. So there's 6 different types of options we could get from this, okay? We're gonna do it a little bit differently. We're going to use the counting principle, okay? Basically, if one event can occur in M ways and another event can occur in N ways, then the number of ways that both events occur is M times N. So this event happened in 3 ways, and that happened in 2 ways, which means it gives me 6 ways. I multiply those numbers together. So instead of drawing it out, I can just multiply those numbers together. Okay?
So easy.
So easy. So I'm taking all of my options from this was the type of board, right? And I'm taking all of my options from the shoe and multiplying them together. If you have 3 or more events, the fundamental counting principle happens the same way. You take event 1 and that total, and you multiply it by event 2's total and by event 3's total. So M times N times P, and you get your method. You would get how many options you have. So, you are framing a picture. The frames are available in 12 different styles. Each style is available in 55 different colors. You also want a blue mat board, which is available in 11 different shades of blue. How many different ways can you frame the picture? What would you do?
We just do 11 times.
Yep, 12 times 55 times 11. Okay? So when I do 12 times 55 times 11, you get 7,260. See, that would be really hard to draw out. Right? So now we just multiply together and get it. So when we're doing counting principles, it's very simple. You just multiply all of them together. Okay. Next, it talks about license plates. The standard configuration for a Texas license plate is 1 letter followed by 2 digits followed by 3 letters. How many different license plates are possible if letters and digits can be repeated? So it's a letter, a digit, a letter, right? How many letters can go in spot 1? 26. How many numbers can go in spot 2?
9.
Okay, think again.
Oh,
That's a trick question.
9.
No. You want to say 9 because you want to say 1, 2, 3, 4, 5, 6, 7, 8, 9. What other number is there that could go there?
10.
Not 10.
0.
0. So there are 10 total possibilities. How many numbers can go again?
10.
10. How many letters?
26.
Letters and letters.
Oh, okay.
Okay? So now we multiply those together and we see how many possibilities there are. Times 10, times 26, times 26, times 26. And you would get, this is your solution. Okay. 45,697,600. Yes?
That's a lot.
It is. But part B says how many different license plates are possible if the letters and digits cannot be repeated. So how many letters could possibly go in the first spot?
If they cannot be repeated.
Yeah.
We'll just do
How many letters could go in the first spot?
26.
26. How many numbers can go in the first spot?
10.
How many numbers could go in the second spot?
Just do
not one. How many numbers possible were there for the first spot?
10.
And how many did you use?
10.
How many have you used in that first spot? There were 10 options, but how many numbers can you actually put in that first spot?
Oh, 1.
One, so then how many numbers are left to be used in the second spot if they can't repeat?
9.
9. How many letters can be put in the second spot?
25.
And how many in the third spot?
24.
And how many in the last spot? Now, if they can't be repeated, we have a different option, yes?
It involves a lot of thinking.
It does, you have to think through things. So this time, you get this as your solution. So, you only have 32,292,000 options if you can't repeat. But if you can repeat, you have almost 13 million more, or a little over 13 million more options. Okay. So, there's something in ordering of options called permutation. It's an ordering of in objects, it's a permutation of the objects. For instance, there are 6 permutations of the letters A, B, and C. Okay, I can rewrite them 6 different ways, put them in 6 orders. That's called a permutation, okay? You can use the fundamental counting principle, what we're talking about here, to find the number of permutations A, B, and C have. There are 3 choices for the first letter. After the first letter has been chosen, there are 2 choices for the next letter, and then there's 1 for the third, yes? Does that make sense? So, if I want to place A, B, C, I could put an A here, a B here, or a C here. So there's 3 options for that. Now, when I go to the second, I only have 2 options left. When I go to the third, I have 1 option left. So I multiply 3 times 2 times 1 together, and I get 6. But that's called a permutation. Okay? The expression 3 times 2 times 1 can also be written as this, right here. 3 with an exclamation point, okay? That exclamation point is called a factorial. The symbol and 3 factorial, well, it's read as 3 factorial. The general n factorial is defined where n is a positive integer, and it follows this pattern. So you would start with n, and then the next spot would be multiplied n minus 1, like we did here. 3, and 3 minus 1 is 2. Okay, and then the next one, and so on and so forth, until you get down to 1. So, on your calculator, you have a factorial that you can use, so that when you have large amount of numbers, like let's say we were doing 25 permutation, it would be 25 times 24 times 23 times 22. Would you want to sit and put that in your calculator? Okay, so we can do 25 permutation, or 25 factorial on our calculator. Depends what calculator you have. If you have that one, let me borrow this. You are going to do, you're going to press 25, and you're going to go under PRB, because that stands for probability, and you're going to find the factorial sign. If you have this calculator, the graphing calculator, you're going to hit 25, and you're going to go to, let me think. Yes, you're going to go to math, hit the math button. Math. Go all the way over to PRB. Now hit find the factorial. Hit it. Oh,
Oh, okay.
okay. And hit enter. And you should get an answer. What did you guys get as your answer if you do 25 factorial? Hit no, you chose the wrong one.
At 1.55.
25. You go over to the factorial. You get 1.55, but then mine says e to the 25th. Okay, so that just means that that's a massive, massive number, okay? So we would write down what we get, okay? Here's what we need to look at now. It says 10 teams are competing in the final round of the Olympic 4-person bobsledding competition. Part A says, in how many different ways can the bobsledding teams finish the competition? Assume there are no ties. How many teams are there? 10. So how many different ways could they finish?
10. Like 10. I got 10 different teams.
There's 10 different teams, which means how many teams have the chance of finishing in first?
10.
10. 10 teams could finish in first. How many could then finish in second? 9. How about third?
8.
Fourth? Okay, fifth? Sixth? Seventh? Eighth, right? Ninth? And 10th, correct? So there are no ties. So that's the option. Now, what does that look like? If I was multiplying that together, what is that called? What do we just talk about? What does that look like? How would I put that in my calculator so I don't have to do 10 times 9 times 8 times 7 times 6 times 5 times 4?
What's that word?
Starts with an F.
Factorial.
Factorial, yes. So what is 10 factorial?
I got 3,628,000.
Good. So there are 3,628,800 possibilities of how those 10 teams could finish. Okay? So that is what factorial does for us. Now, in part B, it says, how many different ways can 3 of the bobsledding teams finish first, second, and third to win the gold, silver, and bronze medals? So how many different ways can 3 of the bobsledding teams finish? This is a little bit trickier. What is it asking us to do on this exactly? Anybody got an idea? What is it asking us to do in that wording?
Is it
What places does it want us to finish?
first, second, and third?
First, second, and third. So we're only focusing on first, second, and third. How many teams could finish first place? 10. How many could finish in third place, second place? 9. And how many could finish in third?
8.
So we're gonna multiply those together. 10 times 9 times 8. 10 times 9 times 8. And you get 720 options. So there are 720 options with how 3 teams can finish in first, second, and third. Okay, there is a formula for this. We're gonna talk about it next. Okay, it is a permutation of n objects taken r at a time. So the number of permutations of r objects taken from a group of n distinct objects is denoted by NPR and is given by this formula. So NPR equals this, guys. NPR equals n factorial over n minus r factorial, meaning this. Here we had 10 ways, 10 teams finishing first through 10th, right? So that's our n, because we have 10 teams to choose from, okay? How many total places did we want here? 3, so we have 3 there, okay? Which means it equals 10 factorial over 10 minus 3 factorial. So you get 10 factorial over 7 factorial. Watch this. If you list out a 10 factorial, it's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, yes? If I list out a 7 factorial, it's 7 times 6 times 5 times 4 times 3 times 2 times 1, yes? What happens here when you have those over top of each other? They cancel. And what are you left with then? What we had here, right? 10 times 9 times 8. Your calculator will do this work for you. Here's how you plug it in.
Oh, that's cool.
Plug in a 10. Go back to where you found that factorial sign. So for you, it's math. For you guys, it's RB, yes? And then you're going to go over and you're going to hit the one that says NPR. Okay? Hit enter on that. And then once you hit that, you have to hit a 3 now, because you're taking 3 of those options, and press enter. 720, which is what we got when we multiplied this together, yes? So it makes it a lot easier, because here's the deal. What happens if this is 25p6? That's going to be harder to multiply out, right, than 10 times 9 times 8. So we can cheat a little with that nice little permutation, okay? That's why I said calculators will be good today. Actually, okay, and then there's one other thing we need to talk about. You are burning a demo CD, or you're burning a CD for your band. Your band has 12 songs stored on your computer. However, you want to put only 4 songs on the CD. In how many orders can you burn 4 of the 12 songs onto your CD? How would you set that up? How
Would
would
you put, like, 12 or something like that?
Okay,
Alright, wait, do we have to do that, or do you want us like to do it for me?
no, you can set it up in a permutation if you want. What would that look like, permutation wise? How many total songs do you have to choose from? 12.
Oh, whoa,
And how many do you want?
4.
4. So how would your permutation be written?
Would it just be like, on the side, 1, 2, 3? Or
Okay, turn it into this form here.
Oh,
So all we have to do is plug it in our calculator.
12, 4.
Yes, 12P4, because I have 12 options and I want 4 of them, which essentially is 12 permutation over 12 minus 4 permutation, right? So plug that in your calculator, what do you get? How many options do you have?
11,000.
11,000, is that what you said? 11,880. Okay, so now I have a permutation of 11,880 options. The last thing we need to discuss is permutations with repetition. This is just practicing permutations. I have no, I don't think you won't be able to plug those in your calculator. Yes, you can do that on your own. You can plug it in your calculator and figure it out. Okay. Last thing is permutations with repetition. If you consider the letters E and E to be distinct, there are 6 permutations of the letters E, E, and Y, okay? Meaning, I consider them 2 separate values, okay, E and E. So then there would be 6 combinations, because it would be 3 times 2 times 1, right? Okay. But if you consider E as interchangeable, then there are only 3 distinguishable permutations. Because if I think that E doesn't count when you repeat it, then it's only represented once, which is a 3 permutation over a 2 permutation, so you get 6 divided by 2, which is 3. Okay, so when you are doing permutations with repetition, you have a formula that looks like this: n factorial over s1 factorial times s2 factorial times s3 factorial, so on and so forth. Meaning, this represents anything that's being repeated. Okay, so for I, or for EEY, you have 3 factorial on top, yes? But how many E's are there? 2. So that goes on bottom here because it has been repeated. There are 2 of them, so I put it on bottom. If there was something else in that group that had 2 or 3 in it, I would then multiply that factorial on bottom as well. So, it takes us to problems like this. Find the number of distinguishable permutations of the letters in Miami and Tallahassee. Okay, how many letters are in Miami?
5.
5. So you have 5 permutation on top. Okay, look at the first letter is M. Does M repeat again? So that's 2 permutation on bottom. Does I repeat again?
Yes.
That's 2 permutation on bottom. Does A repeat again? No. So I have 5 factorial over 2 times 2 factorial. Okay, 5 factorial.
You're just gonna have a really hard time with this one.
You're gonna, Drew is, or you?
Yeah, definitely.
2 factorial times 2 factorial. And what do you get as your answer to that? that you get as your answer to that. Five?
I got 120.
Don't multiply 2 factorial and 2 factorial together to get 4 factorial, because that's different, because that would be 4 times 3 times 2 times 1. You got 120? Nope, listen. This is where you're messing up. You have to put, you need to put parentheses around yours. So you're gonna go 5 factorial divided by parentheses 2, and everybody has to do it this way or it won't come out right. That's why I was asking. Factorial times 2 factorial. And you'll get 30 options. Now, here's why that works this way. Okay, let's take a look at it broken down. Up top, you have 5 times 4 times 3 times 2 times 1, yes? On bottom, you have 2 times 1 and 2 times 1, yes? Okay, so the 1s can cancel out, correct? Okay, this 2 can cancel out, yes? And then this 2 can go into 4 twice. What's 5 times 2?
10.
And what's 10 times 3?
30.
That's why it works that way. So if you're putting it in your calculator with these factorial marks, you have to put it in with parentheses like that, okay? And you're not putting it in as 4 factorial, because 4 factorial is 4 times 3 times 2 times 1. So that would cancel out different things, yes? Okay? That's why we need to take a look at that. Now, let's talk about Tallahassee. How many letters are in Tallahassee?
11.
11. So up top you have 11 factorial. Does the T repeat?
Yeah.
Does A repeat?
Yes.
How many times?
3.
So you have 3 factorial. Does the L repeat?
Mm-hmm.
Okay, twice. Does the H repeat?
Mm-hmm.
S
Yes.
and E, yes? Okay, so you can either put it in your calculator or you can write it out 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 over 3, 2, 1, 2, 1, 2, 1, 2, 1. Yes?
Mm-hmm.
All the ones cancel, I don't need those on the bottom. That 2 can cancel. 2 and 2 is 4, so 4 cancels. 3 and 2 is 6, so 6 cancels, and I would have 11 times 10 times 9 times 8 times 7 times 5 times 3. Or you can put it in your calculator, 11 factorial divided by parentheses 3 factorial times 2 factorial times 2 factorial times 2 factorial, okay?
I don't understand this.
You don't understand this one?
I said I am.
Okay, good.
Now.
And then you would get 8, 3, 1, 6, 0, 0,
You just have to think.
okay? You get 831,600 options for Tallahassee. That is what we are working on in 10-1, and you did a whole lesson in one day, yes.
I think you just have to really like be careful